Hi all, and welcome to week 2. We're doing Venn diagrams and patterns, so you made it through week 1. Let's see what we have in store for week 2. So our objectives for this week: the student will analyze set properties and relationships, including the use of set notation, set operations, and verbal arguments. The student will describe, extend, and analyze problems with number patterns and number properties. So those are the math practices we'll really be focusing on, which you learned in week 1. So MP1, make sense of problems and persevere in solving them. MP2, reason abstractly and quantitatively. MP6, attend to precision. MP7, look for and make use of structure. And MP8, look for and express regularity and repeated reasoning. So keep those in mind every week. So set theory review. Some of you may remember set theory, some of you might not have had a lot of it. But here's a document, and if you click this blue link right here, it will have the symbols for you, and you can look at the examples, and you can put it in your interactive notebook. There's also some games on this next slide that you can play. So the set theory matching activity. So it's a matching game. It's super fun. Let me see if I can show it to you. So here's the game, and you literally drag and drop things. So maybe you know this symbol is the empty set, so you put it there. And then when you're all done, you could screenshot it, and if you're doing an electronic notebook, you could use that. As well as that game, there's other games. There's memory games, a matching game, and then a tug of war about Venn diagrams. And I've put a link to my interactive notebook stuff, so you could find the foldable for the, you can look at the foldable that I have in our sample notebook, and then you can make your own and put it in your notebook to help you study. Attribute blocks. So attribute blocks are a new manipulative for you in math, and you can use them to help concept build many topics like set theory and geometry. So we're going to get to know the pieces. You can print out one of them, or you can go to the website that I'm going to give you where it's interactive. And a set of attribute blocks consists of 5 shapes, usually circle, square, rectangle, and hexagon, and triangle in 3 colors, red, blue, and yellow. And there are 2 sizes, large and small. There's also thick and thin, and you can decide whether you're going to use that or not with your students. So in the attribute blocks, we're going to get to know the pieces. So let me show you what they look like first. So attribute blocks, you can only see part of the screen. Let me see if I can get it in there better for you. So if you look at our attribute blocks, there's a blank screen, and then at the bottom you can see all the different shapes. I'll scroll down so you can see them. And you can drag them onto the screen and use them. You can also use a 1 circle, 2 circle, or 3 circle Venn diagram. So that's very nice. All right, so now that you have that up maybe in another window, we're going to practice getting to know the pieces. So here's like a riddle. I am small but not thin. I have more than 3 sides but fewer than 6. I am yellow. I am not a square. Who am I? So which attribute block are we talking about? So when you teach this to kids, you need to make sure you give them the clues slowly and let them use the pieces and figure out what it is. So I'm going to give you a couple seconds to go ahead and process what shape it must be. And make sure you're very specific, giving all the criteria. So you can pause the video if you need more time, but I'm going to go to the next slide where we talk about what the answer is. So who am I? The answer? Did you figure out that I was describing a small, thick, yellow rectangle? So make sure you had all 4 of those words. You want to be as specific as possible. So small, thick, yellow rectangle. Now let's try another one. I have more than 3 sides, all the same length. I am the color of a stop sign. I am large but not thick. I am not a square. So again, we're trying to see which clues are the most helpful to divvy out which pieces we need to include and which pieces we need to exclude. So I'll give you a few seconds to figure that out. And again, you can pause the video if necessary. So let's see what the answer to this is. Did you figure out that I was describing a large, thin, red hexagon? All right, let's try another one. So for a fun classroom activity, oh, we're not going to try another one. So for a fun classroom activity, you can have students do the following. On a whiteboard, you can have them create their own Who Am I puzzle, and then they can take turns sharing them and solving them. It's a great way for them to internalize the concept and really see if they understand it. So now we can use attribute blocks if we're talking about sets. So this time you're going to use the circles on the screen. So we're going to use 2 hoops and all the attribute pieces in your diagram. And note that when I did this, I did not include thickness. I just left them plain, so we were only using thin. So set A is going to be blue, and set B is going to be triangles. And so you're going to try to arrange all of the shapes into those circles of blue and triangle. You can pause the video here if you're still taking notes or if you want to process this question before you see the answer on the next slide. Okay, so here's the answer. Notice that A union B would be all the blue shapes and all the triangles, and A intersection B would only include blue triangles. So make sure your Venn diagram has all the shapes where they're supposed to be. Good job. Here's another one. Set A this time is going to be blue and set B is going to be thick. Now I only used thick blocks when I was doing it. And when you're done, again, click to the next slide and you can see the answer. All right, pause it if you're not ready. There's the answer. Now notice this time that set B, which is thick, actually contains all the attribute pieces. I don't know if you can tell they're thick. They look like they have a little shadow. That's how you can tell the thick from the thin. Okay? All right. Another one. So set A is blue, set B is red. So it's nice to give students a lot of options when they're doing this, and I did not use thickness in this example when I did it. Okay, make sure you use all your attribute pieces and you pause this slide if you're not ready for the answer yet. And here's the answer. So notice that A intersection B this time is the empty set, because if one set is blue and one set is red, there's no overlap. There's not any pieces that are both blue and red, which is what an intersection is. Sometimes you would use 3 hoops, and if we were in class, we would actually use string, or we would draw big hoops on the tables or on the floor. And this time we're going to use set A is red, set B is circles, and set C is small. Now, make sure that if you're doing this with your class, you step them up, you scaffold them up to first using small and 2, first just getting to know the attribute blocks, then using 2 circle Venn diagrams, and then 3 circles. So, and then after you finish that, try to find A intersection B and A complement. Notice that A with the little tick mark means complement. So if you're not ready for the answer, pause the video and take your notes and then click to the next slide. So here's the answer to the 3 hoops. I didn't draw the picture, but because the attributes online, you can't adjust the size of the circles, so that was a little frustrating. I'm going to ask the person who wrote that manipulative to correct it for me. But A intersection B intersection C would only have one element in it because there's only one that meets all 3 of the criteria, red and small and a circle. And the complement of A would be everything that's not red. A fun classroom activity. I do this I start with 2 in a group, and we call it buddy Venn diagrams. And so then after you do that, you can do it in a group of 3. Each hoop represents a group member, and then you fill in the areas of the Venn diagrams of what they have in common. So, and my directions are 2 things you have in common and 1 thing you think is unique to you. So, and then that's a good way to make sure students are understanding which area of the Venn diagram they're supposed to put objects in or set elements. But we've been making our Venn diagrams. So now, if you click on this blue link, it'll take you to a website where you can make your own Venn diagram. It's pretty easy to follow. You can click help if you need directions. So I want you to make your own Venn diagram using the following information. Be sure you're showing the appropriate membership in set A, B, and C. So the universal set is the numbers 1 through 10. Set A includes the elements 1, 3, 5, 7, and 9. Set B includes the elements 1, 2, 3, 4, and 5. And set C includes the element 3 and 10. So pause the video for a minute, and then the answer will be on the next screen. Okay, did you get it right? Did you place all the elements in the correct places on the Venn diagram? Excellent. So now using that Venn diagram, can you answer the following? A union B, B intersection C, A intersection C, and the complement of B. So pause the slide, answer those questions, and then move on. So here's your answers. Check to see if you got them correct. A union B would be 1, 2, 3, 4, 5, 7, and 9. B intersection C would be 3. A intersection C would be 3. And the complement of B would be 6, 7, 8, 9, and 10. Anything that's not in the B circle. So remember, on A union B, it's everything that's in set A or set B or both set A and set B. Whereas the intersections are, it has to be in both. Okay, so it's an and. And then again, the B complement would be everything not in the B circle. Excellent. So in your notebook, let's compare Venn diagrams and versus or. So I have a foldable for you that you can click on and get it from right here. And then you can cut it out, label it, and we're saying, I'm thinking of a block that's a triangle and large. So you're going to draw in the blocks which go in each region, okay? And then you're going to shade the area that makes that true. So triangle and large. Then inside the foldable, you're going to write the words to describe each region. So this, it tells you where to cut on the dotted lines and everything. And you're only going to cut through the top. You're going to fold the paper and only cut through the top. Here's an example of what it looks like in my notebook. It says I'm thinking of the block that is a triangle and large. So that would be this area that's shaded in the middle. And underneath that, I have these 3 sections labeled. And so if it's an and, it's an intersection, and it must have both attributes. So make sure you take notes on that in your interactive notebook. Now, we discussed what and meant. Now let's talk about or. So I'm thinking of a block that has all equal sides or is a quadrilateral. You're going to take that foldable that I gave you access to and use another one of the Venn diagrams, and you're going to label them like it says, and then you're going to cut along the dotted lines of only the top sheet. So then you can put the attribute blocks where they go. You draw in a sample of what blocks go in each region. And then in the inside, you're going to write the words that describe each region, and you're going to shade the area that meets the criteria of the statement equal sides or a quadrilateral. So take a minute, pause the video if you need to so you can write in your interactive notebook, and then go to the next information, the next slide. So here's my notebook sample. This time, I don't know if you can see that shaded, but it's all of this is shaded. So it could have all sides equal, it could be a quadrilateral, or it could be both. So notice that the union actually includes the overlap. Some people forget that. And then in your inside of your foldable, you're going to write down those words. All right, Now here's an example Venn diagram, and I have the universal set being 1, 2, 3, 5, 6, 7, 8, and 10. And it's asking you, what is A union B, and then what is A intersection B? And so this will give you a good time to practice writing set notation and making sure you understand union versus intersection. So pause the video if you need to. All right, A union B should have been 1, 2, 3, 5, 6, 7, because A union B is everything in A and everything in B and everything in the overlap. That's why 1 and 7 are in A union B. And A intersection B is only this overlap, so only 1 and 7. Notice that I included elements that are in C, but C is not in my question. It's okay because we're just pretending C, that C part that has the 10 in it, doesn't really matter because we're not asking about that. All right, now it's asking you how many elements are belonging to that set. So this time we're asking cardinality. So how many elements belong to set A? How many elements belong to set B? And so on. All right, so the answers to those questions, how many elements belong to set A is 4, how many elements belong to set B is 4, how many elements belong to set A but not in C is 2, and how many elements belong to set B but not set A is also 2. How many elements belong to set A or C is 6. So make sure you get those answers and take notes and make sure you understand that. You have a Canvas assignment that's a worksheet, problem solving with Venn diagrams. So if you want to, you could pause the video right here. You could go do that worksheet. It's going to be time consuming. You have to make sure you follow the directions. Make sure you draw your universal set. A lot of people forget about that. And then write your answer in a complete sentence. So, and there's 5 problems on that worksheet, so it might take you a while, but just know that you should have all the information to do that part. So now we're going to move on to patterns. So let's look at some patterns. You know a lot of these already. So it says, complete the following questions, describe a rule or any pattern you notice. So 3, 5, 7, 9, we want to fill in the next 3 blanks and then write a rule for it. So pause that video, write down your notes, and make sure you write the answers and then the rule. And then when you're ready, click to the next section because it will have the answers. All right, so here's our answers. So notice that I have 11, 13, and 15, but I write that I'm adding 2 to each term. On the next one, I'm multiplying each term by 2. And then on part C, I'm multiplying each term by 1/3, which for some of you, you probably wrote dividing by 3. Make sure you make that connection, that multiplying by 1/3 is the same as dividing by 3. And then the last one was a little bit tricky. Some of you may have remembered it. It's a Fibonacci sequence where the new term is found by adding the 2 previous terms. So for example, to get this 2, I would add 1 plus 1. To get this 3, I would add 1 plus 2. To get the 5, I would add 2 plus 3, and so on. So those are some basic patterns that you probably are familiar with, but now we're going to try to make a name for them. So there's an arithmetic pattern that is a sequence of numbers where the difference between consecutive terms is constant. So in other words, there's a common difference. So here's some examples. Pattern 1, 1, 2, 3, 4, 5. Pattern 2, 2, 4, 6, 8, 10. Pattern 3, 1/3, 1, 5/3, 7/3, and 3. And I know a lot of you are like, ugh, fractions. We need to practice our fractions now, so when we get to the fractions unit, we can do it really easily. So take some time, make sure you find the common difference between the terms. So in pattern 1, I think it's pretty easy. You can see the difference between each term is just a difference of 1. So if I do 2 minus 1, I get 1. If I do 5 minus 4, I still get 1. On pattern 2, now my difference is 2 because 4 minus 2 is 2, 10 minus 8 is 2. So it has a common difference of 2. So on patterns 1 and 2, you can definitely see that they're arithmetic sequences. How about pattern 3? So on pattern 3, we go from 1/3 to 1, then we go to 2/3, then we go to 7/3. So if we were going to subtract 1 minus 1/3, we would get a difference of 2/3. Let's see what we would get if we do 5/3 minus 1. Well, 1 is the same as 3/3, so 5/3 minus 3/3, it is 2/3. So pattern 3 is also arithmetic, but now the common difference is a fraction of 2/3. There's another type of pattern called geometric patterns. So it's where the sequence of numbers is found by multiplying the previous term by a constant, and that constant is called a common ratio. So here's some examples. Pattern 1 is 1, 2, 4, 8, 16. Pattern 2 is 10, 30, 90, 270. And pattern 3 is 4, 2, 1, 1/2, 1/4, and so on. Now notice I read those decimals as fractions. We'll talk about that later in the class. All right, so find the common ratio, that should not say difference, that should say ratio, between the terms. So if I do 2 divided by 1, I get 2. If I do 16 divided by 8, I still get 2. On the next one, if I do 30 divided by 10, I get 3. If I do 270 divided by 90, I still get 3. Now again, pattern 3 is a little bit tricky, but make sure you divide in the correct order. So the new term goes over the previous term. So 2 divided by 4 is 1/2. 1 divided by 2 is 1/2. 1/2 divided by 1 is still 1/2. And 1/4 divided by 1/2 is still 1/2. So the common ratio here is 1/2. So make sure you understand the difference between arithmetic and geometric. There's also visual patterns. So a fun classroom activity is to give students a visual pattern like this. And you want them to describe how the figure is growing. And you want them to be very specific. So think about it and then say as much as you can about the growing pattern. Students will draw to extend the pattern. And then what mathematical questions can you ask about the pattern? And then can you answer those questions? So pause the video right here, draw these figures, see if you can answer those questions. When you're ready, press play again, and I have some sample answers. So here's some sample answers. I didn't include the drawings, but students might say something like, the pattern grows by 1 in the column and by 1 in the row. They may also look at the diagonals. So this just has 1, this on the diagonal has 2, Figure 3 has 3 on the diagonal, Figure 4 has 4 on the diagonal. So they might see something else. That's great. What mathematical questions? Some people would describe the pattern numerically, where they're looking at the number of squares in the figure. For example, there's 1 square here, then there's 3, then there's 6, then there's 10. And when they look at that, the number they're adding each time increases by 1. So first they add 2, then they add 3, then they add 4. And so in your next figure, you could see you would add 5, and so it would have 15 squares. So visual patterns are also, we do this a lot in the lower elementary grades. We talk about A, B patterns, or A, B, C patterns, and so on. You have a worksheet in Canvas about patterns. Some are visual and some are numbers. And after you finish that worksheet, you'll want to think about patterns that exist in number systems, because we're going to investigate a variety of number systems next week. So think about how our number system is set up, because it must be based on patterns. And that will help you in a jump start for week 3. So end of the week check-in. See if you can do the following without your notes. So see if you can identify the next 3 terms in this sequence. See if you can identify it as arithmetic, geometric, or neither, and then explain how you know. And then note that the answer is on the next slide, so pause it if you need to. All right, so we go 20, 16, and 12. It must be an arithmetic sequence since there's a common difference of 4 between consecutive terms. These are great questions for your midterm exam or a quiz, so make sure you're paying attention and you're thinking about your mathematical justification, not just filling in the blanks with the numbers. This week you have a team assignment. Yay! I already put you on teams in Canvas. You even have a group page each team does, and you can see your own group page. Make sure you read through the assignment, and then you reach out to your team members as soon as possible to discuss how you're going to collaborate. Make sure you read the directions carefully. Each team member must solve all 3 problems first. Then you're going to collaborate and practice MP3, which is construct viable arguments and critique the reasoning of others. You're going to look through each other's solutions, agree, disagree, refine them, make sure you're attending to precision, and then you're going to make a final document, and it can be the collaboration from each one of you. Maybe someone did question 1 really well and someone else did question 3 really well. So your final document, you will only submit 1 as a group, and please refer to the rubric if you have any questions. The following week, right after the project is due, you will have team evaluation, so you will be able to evaluate each other. Okay? So make sure you take a look at that early in the week. Yay, you did it! You finished week 2 slides. So you can watch this video as many times as you want. You can look at the slides without the video. They'll be on the classroom presentation page. And then make sure you complete all the assignments in the week 2 module. If you need anything, please reach out to me. You can also post on the FAQ discussion board if you're having trouble and ask questions. If you need anything, you can visit my office hours. If those aren't convenient, send me a message and I will make sure we schedule an appointment at a convenient time. I hope you're doing well and feeling like your interactive notebook is coming along and that you're learning things online. Hooray! I'll see you next week for week 3.